Okay, then welcome everyone to this webinar called The Impact of GenAI on Platform Engineering. So, as the title suggests, we will be discussing GenAI, but we will see a bit what the impact it has on platform engineering on different levels. And for that, I have two awesome guests. I got Elliott and Patrick. They will introduce themselves in a bit. I'm here to moderate, and yeah, please don't be shy in the chat. If you have questions, just drop them there, and I will make sure to pass them along to Patrick or Elliott. And yeah, so I think we can start, and let's start with the intros with our from our guests. So, hi Patrick, how are you? And can you tell us who you are? And yeah, just the floor is yours.
Yeah, certainly, Sebastian. I'm Patrick. I'm from Belgium. And most people actually know me from the world of DevOps, kind of early on, also the DevOps Handbook and DevOps Days. And I think over so many years, I kind of like got a little bit bored, if I'm allowed to say that, of that world. And with the whole GenAI craze, I think my learning passion is getting there again. So I'm happy to share what I learned also already, like implementing the platform team and in the company and kind of like sharing that to others. So that's me.
Okay, awesome, thank you. Elliot, your turn.
Thanks, Sebi. So I'm Elliot. I'm field CTO over here at Port. My background's in engineering and then platform engineering, and now at Port, working with our customers really closely and understanding their needs. And yeah, really excited to be here and to join the conversation about the AI impact on platform engineering, something I'm very interested in and yeah, been following very closely.
Thank you so much, Elliot. And I just realized I forgot to introduce myself. So I'm Sebastien Blanc. You can call me Sebi. I work at Port. I'm the DevRel person, so developer relation. Basically, my job is to make developers happy. Yeah, and my background, I'm a Java developer, and yeah. I'm lately I dived a lot into platform engineering, and of course, as everyone, I'm playing with GenAI. So I'm really interested in hearing your thoughts on all this stuff. So um, I think we will divide the discussion into three main parts, but let's see how it goes. First part, we will see a bit the impact on the infra side. So yeah, me back in 2004 when I was working as a Java developer, what I was doing was writing code and committing that to CVS. And then there was one application server that we were going in production twice a year. And that was more or less the infra we had, and then, yeah, the whole crazy now is to the cloud, microservices, DevOps. Yeah, we had way more components. And now with the, 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 the tsunami of GenAI, we have to deal with a lot of new stuff, and I will let you discuss that. But top of my mind, I see, hey, LLMs, vector databases, MCP servers. These are all kind of new stuff where infra is needed. So yeah, maybe we can start with Patrick and tell us a bit what all those new new toys are.
Yeah, of course, of course. So the most notably, if you ever use ChatGPT, I think nobody on the planet has not used it almost like in that way. There's like a large language model behind this. So the first step that people kind of do in a company is they play with it, like ChatGPT, the first thing, right? A playground, and you have different models, and that's it. So part of the first infrastructure is actually giving access to those playgrounds, which is, kind of a first thing. Now, usually the devs are kind of like, going to the next phase, just give me an API key. Like that typing is really annoying. And they start like sending prompts and kind of like, going back to the model. Now, as they mature, they realize that ChatGPT and the LLMs do not know everything, and especially not within their company. And so they become familiar with a RAG database and a vector database. And it could be, actually the database could be anything, but it is about similarity search. And we've had search in the past, which was, the typical elastic search, the databases, but now all of a sudden we have a component which is semantic search that they're used to. So it's not on the keywords, it's not on the terms, it is on the meaning or the related context that it is. So this is usually the first chat thing. They chat with documents. So they have the vector database, they have those things, and they have the LLM, and kind of they form their first thing to kind of communicate with that. So that's usually the first kind of like rough level of infrastructure that people need. There's loads more, but I'll let Elliott chime in for the next pieces.
Yeah, I mean, there's a ton of new infrastructure that's required. There's also, from not even like the developer perspective, if we think about all the new personas inside of a company that are going to start to produce applications, so there's citizen developers as well, and what they start to engage with. So there's so many new tools like agent frameworks and different things that essentially allow different personas to start to create business applications and business value without necessarily being experts on even software engineering. So this is becoming really interesting. We see tools like Bolt and Lovable, where you can build front ends V0 really, really quickly. And whether it's prototyping and sort of product managers getting involved in the early part of the development lifecycle, even giving more specific sort of designs, or whether it's like other personas inside the business taking care of their own needs. It's really fascinating to see the new types of infrastructure that the company needs to offer and govern in order for all these different personas to succeed. If we think, I didn't really want to use slides today, but I've got one slide that articulates the problem that Sebi was talking to at the beginning, because I also used to code back in the era when it was just, I just write my tests, my application code and my unit tests. I'll just quickly share a quick slide that tells this story quite well. This is where we used to be. Devs wrote code and tests and took a really long time to deliver software because software delivery was gated. We didn't have confidence in what we were delivering. Then DevOps sort of begins. And what we have is, developers owning the application, no more silos, that you own it throughout the life cycle, much shorter cycles, and I'd argue better software delivery. But then sort of what happened around the time when microservices came to be, we ended up with fragmented tool chains, lots of duplication between different teams with very similar needs when it came to the non-functional aspects of software, and lots of undifferentiated work between different apps and teams. So the sort of overwhelming of developers became really big. And if we think about this now, we almost have a new era where with AI, we're going to be generating so much more code and so many more developers and so many more components and even more fragmentation of the tool chain. I, for one, am struggling to keep up with all the different versions of the same type of tooling that exists now. So we can sort of think about this problem sort of accelerating in this new era as well. So there are plenty of different tool types and different providers for each one, and even more to sort of be understood and managed.
Yeah, I can maybe add to that. So I first referenced a bunch of components that are used to build products powered by AI, right? This is the business functionality. You add new components to your stack that you're developing. What you kind of described was, doing better engineering with AI, right? All the tools that help us write code. And so I see it often that they struggle with the first one, kind of, which were all the components that we need to use in the product. And then companies actually start the second thread that you described is, let's get them excited about AI in their own tooling in the hope that actually they start building more into the product. So those two threads are like interlinked in many of those companies as well. And so they have similarities, but they're usually an editor and a sauce that's being used. So I think the job there usually of a platform team is to make, similar to the playgrounds I mentioned in the first part, is to make those coding tools available as well. Now, they might not have to run infrastructure for all that stuff. That's maybe done by another person, but it's still the same thing. So you have to find models in the first piece for the product. You have to find the best tool to do your thing on the other side. So the both threads are really in parallel in many of those companies. I don't know if you've seen kind of similar trains of thought in companies or.
Yeah, definitely. There's definitely the enablement part. So getting engineers comfortable with the different components and infrastructure they can use inside their applications, but then also accelerating software development itself with, AI assistants, AI agents, finding ways to accelerate this SDLC itself. So both are, yeah, two different threads, but there are even more tools in terms of the toolbox for developers, as well as tools to help them throughout the SDLC in terms of writing the code, reviewing the code, getting it to production. And yeah, it's interesting to think about also how, as software development changes, developers are spending different amounts of time in different places, sort of different bottlenecks sort of arise, where we'd sort of spend more time perhaps writing code. We now possibly spend more time reviewing and integrating code. And this sort of creates new needs and new problems to be managed inside of an organization to make sure that we still improve in terms of our lead time and getting value to customers quickly.
Yeah, and I would add speaking of bottlenecks, right? So we gotten used to, and we hope finally AI is going to help us write better tests, actually tests in just in general, that it will actually help us with that. One of the things that I find with developers building AI inside of the product struggle with is actually, how do you test that stuff? That's non-deterministic. So in their head, a test succeeds or it doesn't. But in this new world, it kind of works sometimes and it doesn't. Now, as an ops person myself, I'm used to this. I'm used to production seeing weird stuff. But as a developer, this is one of the the biggest bottlenecks for them to kind of go into that field of testing. What's your experience there on that level?
Yeah, I mean, it's really hard to sort of, verify software in traditional means, right? And yeah, whether it's sort of looking at the output and trying to see like the range of responses or looking for toxic output. There are different approaches that I've seen out there, but yeah, this is really where people are at. They're still getting used to playing with the toys and discovering the problems. I don't think that we've seen yet like a really great set of practices in terms of the testing side of things and verification of software. But one theme that comes up quite regularly is it's taking ages to integrate code. We've got this big monorepo. We've got like a very long merge queue, even more changes to push through the merge queue. We're running a huge set of unit and integration tests and end-to-end tests. And what's sort of coming up is this idea that maybe the traditional testing pyramid that we all learned a long time ago is maybe not suited to our current needs today, where perhaps the testing of a unit of code, especially if that unit of code changes really regularly, might be time really poorly spent. And yeah, we're seeing some customers with a desire to potentially select the right test for the change that they're actually working on, and maybe taking a focus on integration and end-to-end tests, maybe looking to really lock down particular units of code. If there's one utility function or library that needs to remain relatively static, it has a really clear contract with other applications, focusing on unit testing there. So it's really interesting to see, as this sort of new bottleneck arises in integration, the sort of desire for customers to maybe depart from traditional methods and find new ways of verifying code. Maybe not that don't really have an answer for the non-deterministic part, but even for the deterministic elements of the code, as more code is being generated by these tools, how do we accelerate the integration itself is quite a common theme.
So what in the field of building product AI inside of your product, the space you want to look at is called evaluations, evals, right? That's kind of running this. And one of the concepts of the evals is, what better way to kind of check the output of AI than to use more AI, right? Which is kind of like, gets inside of my head, but it's definitely, they call this LLM as a judge. So they judge kind of what the other is outputting. And I think that's also what we're going to see more and more being automated with kind of guidelines on the code generation in that field as well. But again, today it says it's okay. Tomorrow it says like, you switch a model, it
Yeah.
gives a different answer. So this is the really fun world that you, as a platform team, need to kind of help your team through. Like, okay, how does it work? It's non-deterministic, but what can we do? And kind of, initially a lot of the companies were like, hey, we finally got it to work, which was great, right? It's the first step to making money, and I get that. But it's amazing that, like, at the last conference, it's almost like, the what's his name, Steve Ballmer impersonation, evals, and you would kind of like completely go, and that's kind of, to go faster, you need better breaks, and that's kind of like where one of the challenges lies in our industry as well. So
yeah. No, testing is for sure a funny one. I know with some friends we wrote a simple bot that generates jokes, because that's a bit the hello word from
yeah.
And then we say, okay, let's write a unit test to see if the joke is funny or not. And we did exactly what you said. We picked another LLM asking, hey, is this joke funny or not? And you cannot really trust the result, but it's really funny to use other LLMs to check output from other LLMs. And speaking of different LLMs, also, if we speak about infra, are a bit orchestration layers of different AI agents, and that is also something new. I think that comes into the whole pipeline of software development. Yeah, we need a new orchestration component as well. And um, maybe
Yeah.
you can you tell a bit about that?
So,
Or
for those familiar with SDKs like LangChain and Llama
yeah,
Index, within that world, they all called orchestration frameworks. For us as a platform team, it feels weird. What are they orchestrating, right? But
exactly.
it's the same thing. Evals, and then we have observability. They have different meanings in the two different worlds. But kind of those SDKs, and Elliott referred to that, like those frameworks. You could, of course, build everything yourself with a direct API, but we're not doing that anymore for other things. We write abstractions above this because we wanted, like we wanted to switch the cloud, we wanted to switch the LLMs, we wanted to switch vector database, we want to switch to the others. Now, early on, what I saw is that people got really excited about these frameworks the first couple of months, and then they hated them with a passion as a developer. And why was that? They were moving so fast, they were optimized on changing all the time and not being stable. Hey, this is breaking. We don't care about the stability right now, which is, kind of acceptable in that state. But that's why people hated them, because it was an abstraction that failed, that they couldn't understand as a developer. And they said, well, I can do this much faster with a direct API. Now, the problem is, if you keep doing this, you're basically building your own set of everything yourself.
Yeah, the
You would have to
shadowing.
build in your own debugging, your logger, your proxy, and all those pieces. And that is very costly. So you might have saved a little bit, like, hey, this is a lot easier. Now, I think we're at the state now, roughly a year and a half, 2 years, that those kind of frameworks have understood that. They pushed out all the craft on, this is a user library, this is a vendor library, this is not core library. And those tools actually got a lot better. So now when you pick one of those SDKs and frameworks, they come with a lot of nice things out of the box. Like much as, a developer would love to kind of see that you don't have to cobble and kind of like, wire everything yourself together.
Yeah. No. For instance, LangJ, I'm a Java user, so I'm using LangJ for J. And it has become a bit the hibernate of LLMs, because I can abstract away I have my AI service, and then I can just plug different LLMs, and I don't change my code. It's it's like magic. And but yeah. And Elliott, anything you would like to add to this? Yeah.
Yeah, it's really much the same of what platform engineers are trying to do with other components inside of
Exactly.
their organization, right? Create paved paths to help developers and enable developers and empower them, not just like enable, hey, it's all on you, take care of it. Like we did in the early days, it's sort of the more platform engineering approach. How do we give them the right tools to be successful instead of leaving them to their own devices to pick the right everything and wire it all together and try to be successful on their own. So yeah, absolutely. Finding the right tools. And luckily, as Patrick said, it's been enough time now that some of the frameworks are becoming mature enough to use and be quite stable. You can be a lot more successful and ship more value because you're not left sort of building everything from scratch. So yeah, it's really like, while the term seems overloaded when we talk about orchestration, it's really the same thing. It's the abstraction that we're giving to developers to enable them and empower them to be successful.
Yeah.
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 I think there's one problem that the SDKs haven't figured out, and that is the same prompt behaves differently on different models.
Yeah.
So if I change something to another model, what do? We already mentioned evals and testing, which is great, but it feels like this is a very almost like technical depth point, or like, every time something changes, I'll have to revise that. And then I have to version control my prompts and have to see which one worked for which model. I have to do A/B testing, what the customer likes as the output. So that's still a challenge and a quite costly one to switch out. It's not like the cloud, oh, we'll switch to one of the providers. Yes, some of the functionality is not there. This is like, okay, upgrade a model, different behavior completely. So that's challenging. And even naming the models has been hard. It has proved by, OpenAI and Google and crazy names. And I think they could use some semantic versioning as we were used to, but it because it's so different, it's not an upgrade. It's always something completely different. And I'm not sure how people deal with it. Besides kind of the vibe check, and that's where the word vibe coding came from. I think it feels okay today, which is great. And then you have another problem that if you're a provider, let's say Amazon, you use that model in US East, you use it in Europe, you use it somewhere else. It has the same name, has different results.
Oh my God. Yeah. That's
Wild.
Anyway, there's a lot of challenges in this new world. So
yeah. And maybe that's interesting. Do you see in the future platform teams using more and more on-prem or in-house LLMs rather than available SaaS LLMs? Is that something that you, or it will always be a mix? I think just like the cloud, but yeah, are we seeing a trend of yeah?
So
And you
there's
have the infra for
initially it was
training
all
those
about OpenAI having these service. I think others came, Anthropic came, Llama came, kind of that like improved things. It is still challenging to get the same quality level with the open source one, but there could be reasons. One could be, I don't want to like send something to an external party, which is understandable and in a way not, because if you're used to cloud, you're also doing something externally. So it's like trusting your cloud partner, but maybe in this new world, you don't know who to trust yet. So that could be one of the problems. And then sending over PII, maybe more regulated environment, could be another one that you want to do. Another reason could be cost. You don't always need, the fancy latest LLM. So I run this in batch. It's going to be way faster if I spin up kind of those LLMs. So there's lots of cases where there is a usual thing to kind of like, go with an on-prem. Well, it's not really an on-prem. It's like on clouds, on cloud, because on-prem is, if you run the hardware, still for me, I'm that old, but but kind of that level. And it's nice that other vendors like Microsoft, Amazon, they allow you to actually run it in your VPC, so as a service. So that's kind of a hybrid way between bringing your own model versus kind of like, being more private. There's still the scrutiny of like, who do we trust with the opt-in, opt-out? That's another of those reasons. I'm sure you have good stories on that as well. So,
and we got a great question from the audience. I'm just reading it out. It says, you're speaking primarily of new projects here, it seems. don't think that too complicated. The big problem is legacy code, 10 or 15-year-old DevOps code base. Any ideas? So yeah, that's a great point. How do we migrate legacy code to this new GenAI world? Well, I think platform team can help with that, but I will let you discuss that.
Yeah, I mean, I think that this is a existing problem even long before sort of AI's ubiquity and the current hype cycle. It's something that's been a long problem because the way I sort of think about it, and I'm sorry to go to slides once more, but I've got actually a nice visual here that tells the story reasonably well. I sort of think a bit of platforms like archaeological strata. So you're going to you see like the Greek civilization and Romans built on top, so on and so forth. I sort of think about like platforms a bit like this. It evolves like strata. We've got the oldest way of doing things, the oldest legacy. Then we've got 5 years ago, best practice, our last attempt at a sort of unified platform, and then our latest reference architecture. And it sort of builds on top of one layer builds on top of the one before. We end up in this problem where we're trying to sort of have one set of platform orchestration, defining how code gets to customers, the guardrails, the governance of how it gets there. But we're sort of trying to measure different things. And I think really the first step, whether it's for adoption of AI or any other sort of modernization project, you sort of have to understand what exists and what value it brings to the customer. So like not just the technological context of what constitutes that application, but what purpose does it solve? How mission critical is it? Which like domain does it belong to? Which customers does it serve? So that we can actually start to maybe come up with policies about either its modernization, what tools should be part of its delivery, or what infrastructure can be included within it. So can we start to work with AI? Is it something we're allowing to be used with that version of legacy? Is it something that we're willing to do when we haven't addressed certain other remaining governance issues? So I'd say that the most fundamental step is essentially to map out all of the legacy and understand what's there and ask as a business, what risks are we trying to mitigate? What risk would really affect us at any particular level before coming up with like guardrails and a means to sort of protect the developer.
Really nice. And you made a super cool transition to the next part of this discussion where we discuss a bit governance and yeah, what's the ownership of the AI stack? Yeah, who's responsible for the LLMs? Is it the data science teams or is it the platform team that needs to streamline? Who is handling the system, the instruction prompts? So how is your team structure? We speak a lot when we speak about platform engineering, about team topologies. Is it still valid with all this Gen AI? Yeah, I'm curious what your opinions are on this part. So Patrick, maybe?
Yeah. So let me finish off the train of thought of the question of, the complicated things, right?
Yeah.
So
Yeah, sure.
when I'm new to a code base, I want to ask questions. Like if the developer would have been there, I would ask questions, right? So it's the first thing that could be really helpful for LLMs to question, where is this used? How is this used? Produce me some documentation, right? It's not going to be perfect, but it saves quite some time. And I know in the beginning, it also kind of depends on how far your tools are on the newer technology, which is a little bit weird to say, but imagine, I would say, a Copilot, from half a year ago would have had a lot of trouble with that. Right now, something like Augment that indexes your whole code base in the cloud will have a better chance at kind of solving some of those problems, right? So you kind of have to see also what is kind of like, the newer technology compared to your past experiences in that. So now that kind of learning is instrumental to kind of get people going. And then the code can kind of, help you guide through one of the rewrites. Now, coming back to your question on more of governance and team structure, I personally, when I was working at a company and at that time, GenAI came in, I looked at the teams we had. We had a really great data team, really good. They had MLOps, all the stuff, really great. They're building models, training, data lake, all that stuff. We had the cloud team, which was managing the Kubernetes, kind of, you know, the data dogs and all those kind of like things in the world. And then we had a third team, which was the developer experience team that was helping kind of, you know, devs with their standard blueprints and kind of, you know, the catalog and all that stuff. Now, what I did was I brought in, I looked at all of them and I said, GenAI is another set of infra. It's not about the training of the model. It is about its own LLMs and vector databases and all those pieces. So the way that I thought about it is actually they all belong in some way in a platform team. So what I did is I had a global structure, which was a platform team, and underneath I had the cloud platform team, the app platform team, the data platform team, and a GenAI platform team. Now that cross-pollinated things like, hey, we need an app library and access to this thing, and that was the cloud team. And so that kind of brought in a structure. So they all fit under the structure of a platform team. Now, the biggest discussion was in the beginning, does AI live in the data part or does it live in the engineering part? And that we found is that actually, compared to the past AI or the traditional ML, we found that this is more about writing applications with integrations. So it sit more naturally within actually the production and the engineering side. So that what we did is actually we said, hey, if we have the data team that can stay on its own, but we're just going to extract a piece of data platform and put that in the platform team. And that could be almost like a feature team, like the mobile team, the data team. It doesn't matter, but we're all putting it under the same umbrella. And all of those teams actually have infrastructure. Of course, they have their own set and their own specialty. So you don't have to learn all, you know, the things, which is a broad spectrum because platform engineers are really specialized. Then they all have to do enablement. The cloud ones was about like, oh, monitoring, make sure you have the right Docker files, the images are trusted, and so on. The apps was, okay, here's your libraries for, you know, Java, Node.js, TypeScript, and all that stuff. And then the GenAI was, this is how you build with LLMs and agents. So they all had kind of an enablement part of it on top of that infrastructure. And then they all needed to have governance, which was, you know, for LLMs, that would have meant, you know, you can't just use blindly a model from the internet. It needs to be vetted. You cannot just use, you know, you have guardrails of input and outputs that you're allowed to send over your prompts. And so all those things have infrastructure, enablement, and actually governance on top of that. So we just copied the platform team topologies model to fit them in and kind of brought them under the same umbrella there.
Super interesting. Elliott, anything to comment or to share around this?
This is very much the sort of model we're seeing out there with different customers that we're speaking to, where there's sort of delineation between more the ML work and the data work that becomes part of the platform team, and then AI capabilities that just become new types of infrastructure that our applications use. So it's very much with the application teams. Something you raised there, Patrick, around the governance, you know, within platform, and then also the enablement piece for developers. Something I'm really eager to pick your brain on is actually how do platform engineers go about doing the governance and enablement of new tools? They're so new, not everyone has so much familiarity with them. We've got new componentry to enable developers with. We were discussing just the example of prompts earlier and the different behavior between different LLMs with the same prompt. How do we, whether it's at the prompt engineering level, whether it's like dealing with the infrastructure itself, how are platform engineers and engineering teams coming up to speed to sort of deal with the governance and enablement piece with relatively new technology they might not be dealing with day to day in their team?
I think it's actually an innovation or technology adoption pattern. So when something's new, what usually happens is we find one team that actually starts playing with it, right? You know, in Agile, this was the Agile team. In DevOps, this was the DevOps team. Like, you know, now it's going to be the chat or whatever AI team or that you call it. So the one team is going on kind of first kind of enablement. Now, when you're a platform team, you kind of have to recognize that this is something you want to scale out. So what you do is you think of this as a customer that actually has a new requirement where you see business in. So thinking as a product, I'm going to help that customer because I need to learn about the stuff that they're doing. And I'm just going to be the person that's really helpful to them because they don't know, Docker containers, Kubernetes to deploy all that stuff. They don't know access control. So you are a natural ally to go into that team that they're developing. Now, then the next thing is you got something going, they're happy, you kind of learn. Then what usually happens is there's a second theme. And then what you are to do is, well, let's see if we can reproduce what the first team did. And then you kind of see, okay, that's a little bit different. Oh, that's the same. And so after 2 or 3 themes and kind of that you're working with, you start seeing the shared components that they all need. The vector database, the infra, the proxy, access to the LLMs. And so what you then do is, okay, whatever you learned in kind of those different teams, you have it sync inside of your platform. So anyway, that's kind of the typical adoption, and it's happened with kind of other DevOps and other movements, but it's a normal progression of you learning, supporting other teams with a new technology that comes into a new organization there. So
that's super interesting. One thing that I heard of from one customer is this pattern of sort of secondments, especially when dealing with new technologies, taking application developers and platform engineers and swapping teams, especially with those who are more at the cutting edge of AI adoption, bringing a platform engineer into that team, learning their practices, working on a sprint or two or a cycle or two of product development, and vice versa. The developer sort of working on the platform team, understanding the need to govern and those sort of requirements can sort of bring a bit of cross-pollination, like you're saying, and different perspectives and at very least empathy. So that when you're starting to get these guardrails and different things and you feel restricted, you can actually understand the problem well. This is really simple at a single team scale, but at company-wide scale, it becomes a much more challenging problem, bigger cost problem, security problem, compliance problem. So yeah, it's a really interesting practice that I've heard of.
Yeah, and it's you remember that we used to say there was a silos between dev and ops. Initially in this whole thing, in lots of companies, the data and the engineering were 2 silos that were not really talking, right? ML ops went into their own land. It was not yet that related. It could have been, but it wasn't for some reason historically. The paths didn't maybe merged enough, or it was less on production focus and more on analytics and data gathering. But it's nice that like somebody called it almost like the shift right from bring the data folks actually closer to production where kind of the value was in this kind of new thing. And so bringing those people in was instrumental for developers to understand, well, what's this natural language do, and which embeddings do I need to pick, and what models work, and how do I do my testing with e-files? So that bring that kind of expertise. And then it's like, how do you deploy, how do you do monitoring, and kind of that, like bringing those teams together was kind of instrumental in that way. So cross-pollination, cross-teams experiences is still definitely help. Now, whether that will stay like that, I don't know. Maybe the teams will get smaller, with the world of AI, and kind of like, everybody can do everything now with AI. That's a very interesting kind of like, peace of mind. So
cool. We get more questions from the audience. I love that when it's interactive like that. Let me start first, the one from Nitesh, and I think we more or less answered, but he goes a bit more into the details. He says, have you seen anyone who has production-ready AI-assisted platform engineering setups? How do they solve the problem of consistency in output, especially Terraform or Kubernetes manifest? That's true. If you ask your agent to produce, I don't know, a deployment manifest or a Terraform, how are you make you sure that it's doing the right thing? Yeah. Is that something that you have seen?
Yeah. So a lot of people tell me that the LLMs are not good for Terraform and infrastructure as code. Somebody thought about this as saying, well, this is usually kept more internal than kind of code on GitHub. We don't share our code too often about our internal infrastructure, so it's less strained of those things. So that could be one of the reasons why it's not there. Now, there's another reason, and somebody from HashiCorp said it. Let's say I tell you, please create me an S3 bucket. Going to a company, going to 10 different companies, that has 10 different meanings. Well, for this one, I need to enable this flag. For that, oh no, it needs to be like this. So there's a lot of confusion on what it actually should be in a certain way. And that's, in a way, the language is simpler because it's a more defined language than a free form Java. You can build anything. But on the other hand, it seems like due to that condensed way of expressing, you don't actually know what it means. So you have to kind of be quite elaborate, and then you could as well write your code. Now, it doesn't mean it cannot correct or help you with the code, but those are some of the things there. Now, there's vendors who kind of add more documentation about the Terraform and stuff, so it becomes better, similar to the RAG that we discussed. And there may be some custom embeddings that find some pieces in the code that are related to other pieces of the code. So definitely kind of companies are improving this. But if you just use the vanilla, maybe large language model out of the box, it might not be that good of experience right now as it could have been. So.
Yeah. I saw pretty good results with Cloud for JSON and YAML generic.
Yeah.
If you give a lot of good examples, that is also, and we come back to prompt engineering. We should get the instruction streamlined from the platform team, and then okay. Anything to add to this, Elliott? Because
one sort of pattern that I've seen work a bit better than trying to enable teams to just generate their ISE and sort of make it a bit easier to deal with ISE is still for the sort of platform engineers to build a developer platform. They'll have sort of abstractions over different ISE templates, either in Terraform modules, or they'll have a Helm chart that eventually will go and deploy some through ISE something to some cloud somewhere. What I've seen be quite successful is, instead of focusing on enabling developers to go off the paved path with ISE generation, to make the paved path even easier to adopt. So instead of forcing some sort of domain-specific language onto the developers, here's Helm charts, you have to understand the parameters, you have to fill in the details correctly, sort of smoothing out that experience with AI. So giving them the ability to fill their templates a bit more easier, or make it an easier sort of chat-based experience, or giving them an agent that they can sort of delegate to go and do certain tasks. It can just be an easier way to sort of make the paved path even more smoothly paved. So it's not like a gravel path, it's like a beautiful concrete path, instead of being something a bit harder to use. And then in that sense, you're still enabling the developers, they're still deploying all the infrastructure that they need for the applications. They just don't have to go and generate the ISE for themselves. Even if the ISE generation was really good, I'd really question whether it's the right thing for the developers to then be going and reading the ISE, assessing it. I think that's sort of the wrong direction. I think perhaps it's useful as a sort of co-pilot for the platform engineer. But I think if we're talking about the developer's workflow, the right way to go about it is less to sort of make ISE more accessible to the developer, but make the paved paths even more smooth and easy to use.
Sure. You abstract it away for the people who, it's not their core, but for the others, it's kind of helping in that way. I think it's interesting that there's another piece that we haven't really discussed is, let's say I say, please do an S3 bucket. Okay, we'll have a hard time, and I'm going to go with that. But imagine, add me something to a VPC, and it just makes up the VPC numbers, right? So what you can do is now you actually take an MCP server, hook it up with actually your test environment, or the other thing could also be point it to your platform documentation as well, and kind of use that as context. So it can't just generate random numbers of a VPC ID. It actually knows from the MCP, it fetches it. It's well, the VPC IDs are like this. That's the trivial example, but maybe some pieces of the infrastructure cannot happen because of that. So you got to give more context, and either that is documentation that the platform engineering, right? Just to, these are the ways we do things, or here are the examples as Sebastien told us. And then this is actually what production looks like. So don't invent your own thing, but kind of like have it verify what it goes there. So a lot of things to improve. And we're just seeing kind of people working on that stuff, and it might not be too easy, like press a button and done, but it's definitely technology that's more and more becoming accessible in all of the tools, especially the MCP part. So
MCP is a really interesting one, and we're seeing such interest from customers in how can I bring port context to MCP specifically. I'm working, I'm coding, I'm addressing incidents, I'm looking at software vulnerabilities. How can I actually take advantage of some of that rich context so that I can get better results? I'm not getting random VPC numbers or things that don't exist. I can actually look up data that my platform team has already gone to all the effort of cataloging, can look at all the self-service capabilities that they've already provided me, maybe take advantage of it earlier in the development cycle. So I'll actually share really quickly a demo though. I've got
exciting. We have some
this
demo time.
Yeah, because it doesn't always go well, especially when we're talking about non-deterministic systems, right? You can see the port MCP server here. Got a bunch of different capabilities. It can create my scorecards, my blueprints, which help me model my data, invoke AI agents, another feature that we've got, which is really exciting. But if I just go ahead, here's a use case. I've got a PagerDuty incident, and I really want to understand what the impact is, which customers are affected. And I don't want to just know in general, like, any customer, I want to know based on a feature, right? Based on the fact it's the admin service, who's opted into certain feature flags. And also I want to know based on the region, EU region. I don't want to be talking about all customers. I've got multiple tenants. I want to make sure I'm dealing with the right ones. So let's see how this goes. Essentially, for those who aren't so familiar, MCP just basically gives the LLM a bunch of tools that it can use to sort of come up with better answers and understand things better. It's almost like its own guide to calling APIs or getting things done. So here we can see that first it looks up the incident from port, gets a list of all of my blueprints, which is the modeling of different things in my universe using my own ubiquitous language. We take a look at some of the running services that are impacted. We're looking at the service that's related to it and a bunch of customers. And here we can see that the LLM is giving me a nice prompt. We can see these are all publicly referenceable customers. So don't worry, there's no data leak here. But we can see that the customers who are affected in the EU region specifically for this service are these three. Now, this is a demo example. I'm not talking about a real incident that occurred, but you can see the power of leveraging all of that data work that the platform team has done and also the self-service capabilities that have been provided to me. I could then go and take it another step further, perhaps to actually create a status page for it, or possibly to send some sort of notice to the affected customers. So it sort of becomes this huge point of leverage, the data that we've got, this clean data, and it allows us to go and use the creativity and the ability to generate that the LMs give us and provide a lot more value to our teams.
I mean, for those who are wondering how that, magic works, I always explain it like this. So you're just use ChatGPT. There's nothing like special. You just type text and it goes text. Imagine your first thing is, I have 15 tools. The first tool is very good at checking which is the port on whatever. The second tool is really good at this. And then you kind of continue. And then you say, given this problem, which tools should I use? So that's kind of how it actually works under the hood. So the MCP server publishes a list of tools with a description, and it feeds that into the LLM like a traditional prompt. And then one of the things it says, pick the right tool, and then call that tool with kind of the arguments you think it's useful. So a lot of people are thinking MCP, something weird, but it's nothing more complicated than a really smart, populated prompt that goes into your chat and kind of selects the right tool and then kind of takes that tool and go there. So that's kind of been an amazing extension in all the tools. The quality of the results is definitely improving because we know the more context we give the LLMs, actually the better results it can give and the more it understands about our problem. So, one thing is, if you have a problem with AI, you use more AI, or you can give it more context. That's also another good solution as well.
And just to wrap up a bit about the MCP part, so you can also directly integrate the port MCP server that we saw in your IDE, like in Cursor, and then you can select some code and say, hey, who wrote that part of the code, who made some changes, and of course you could go to GitHub and do it yourself, but here, well, Port has the whole overview of it, and okay, maybe create me a blueprint that represents this. It's yeah, you can do crazy things about it. And just to completely wrap up on the MCP, and it's a shameless plug, but if you are interested in how to leveraging the metadata around MCP, because in the end it's tools and prompts that you want to manage in your platform team, tomorrow for the CNCF I'm giving a live talk. I give you the link here in the chat, and I will explain a bit what MCP is, but then I will explain you how you can leverage the metadata around MCP. So that was just my shameless plug. I put the link, you can register. We have a few more, yeah, the time is running, and there are a few more questions I really want. People are asking pretty good questions. So let me see. Henry, he is asking, do you think we will have specialized agents for different parts of the stack, or just a single all-knowing agent? Well, monolith or microservice?
Okay. So what I see in the current tooling, like the cursors and root code and others, they're moving towards obviously agents, but they have a way of setting up an agent with a certain context or a system prompt. They say, you're a really good developer, and that sets the stage of giving better results for coding. You're a very good tester, that gives better results. But then somebody has to kind of bring all the views together. And I remember one of the demos I tried, like, with CrewAI in the beginning, one of those agent frameworks. I had a dev, an ops, and a DevSecOps kind of try to come up with the simplest example to list the current directory, right? We all know it's ls, it's like 2 letters. You cannot imagine what happened. Like, the DevOps person said, well, I think you should check whether it's Ubuntu or Debian. Added more complexity. The dev said, well, I'm probably at 2 more features to list, like, kind of more complex things. So the ls became a lot more complex. And the DevSecOps said they should test its root, and kind of do, and check, whether it's not a tainted library. And it just became more complex. And then in the end, I had one orchestrator who said, like, okay, cool down, make the simplest solution, and then it brought it back together. So it's almost like humans. You have the diversity of thought, and you can set up a different agent, different model. You can have them criticize each other, like we said already, LLM as a judge, and then we kind of brought it down. So I don't believe in the one agent that kind of like has that, because that would have a large prompt. It would get confused. It would like had to have all the knowledge. And I don't think the tools are currently there that like this actually works. So kind of making smaller pieces, the same thing, like, smaller pieces of code, smaller pieces of changes is definitely improving the results with the current tooling as well.
That's definitely what we're seeing as well. Multi-agent approach, having agents for very specific tasks with very specific prompts tend to be the way to go. So I was working closely with our own team that developed the Port AI Agents feature, which is essentially a way for the platform engineer to define different agents that will assist developers, whether it's like a security issue deduplicator, or whether it's like a Jira context adder, or very specific agents that help with different tasks. We found that the more specific we got and the more guidance we gave in both the system prompt for the agents, but then also that the platform engineer gives inside the prompt before the developer uses, they almost have their own sort of system prompt that they can give, the much better the results. So I think the more specific we can get with the agents, the much better the and the outcomes will be, even if it comes down to, code review for very specific things, like code review for style, code review for maybe semantic meaning, for, intrinsic documentation, all these types of things I think are typically a lot more effective than trying to overload the agent with too many tasks.
It's not something I got confirmed officially, but what I heard is that, GitHub Copilot internally is 5 or 6 models Like it's not one model that like solve all the things. And so we mentioned that, oh, the prompt could be different, the context could be different. But what you also see is that people have different models. Like we have reasoning models, we have traditional kind of LLM, chat-based models. You start seeing now agentic models. So also there's a variety between kind of like different pieces, kind of combining the best what needs to be done on a specific task and get better results. So lots of room for improvement there as well. So yeah, I see in the chat somebody answers that Copilot uses the Codex model. That's what you see in your interface, and it's one of those models, but it's not the only model internally that is being used there as well. So thank you for sharing.
And I see a question in the Q&A section, because we have a Q&A section, I just realized. But
of course we have a Q&A section.
Yeah. And I think this one, because I know you have been working on a landscape of AI tools. Is that correct? We have someone there. I just summarize. He says, I'm a AWS AI practitioner, but I'm really confused from where to get started and continue my journey in LangChain, in LangGraph, creating agentic AIs, doing MCP. Please help me in getting the roadmap on how to get started and from where to start. So maybe.
Yeah, I would, my first kind of answer would be, forget a little bit first about agents, right?
Yeah.
Do the simple prompting, then kind of go into understanding RAG and bringing more context into this. Then understand a little bit more on function calling, and then kind of go to more MCP kind of integrations. And then an agent actually also adds memory to these pieces and brings them all together, right? Now, it is, pieces, and Sebastien already mentioned it, like I curate a landscape.ai native.io, which has a bunch of tools. But if you want to have like great training videos on those pieces as well, go to deeplearning.ai. They have like amazing, explainers on all of the components that I mentioned to you, and kind of build a problem that's near and dear to your heart. And first try to solve it with prompt, then try to improve it with more context. And that's kind of how I would kind of go with that. LangGraph is a little bit of an odd thing. It is a different way of more structuring how things get executed. So that's more of an orchestration. So it's definitely not the piece that I would try to do first. So try to understand a little bit of the kind of building blocks while you're building up, and then kind of go into more bigger pieces. Whatever framework, a Llama index, I think AWS now released Strands as one of their SDKs. So, try to pick one that actually looks interesting and easy enough for you that you understand the syntax, because under the hood, they're kind of all doing the same things anyway. So.
Yeah, I completely agree with that advice. I'd use an analogy that we've all probably heard before, which is someone asking you, how do I learn how to code? Maybe they would have asked like a few years ago, how do I learn how to code? And, they start asking you about programming languages. And really, it's quite irrelevant. Like, you need to understand the fundamentals of programming. Okay, how does it work? What are the different components and things that I need to understand about how it executes? Everything else. So I'd say it's, like Patrick said, about understanding the fundamental building blocks of what you're dealing with rather than picking specific frameworks. I'd say just understanding what job that component is that you're playing with right now does, and then sort of expanding from there, understanding, and like Patrick said, picking a project that's near to your heart, finding a practical example to experiment with. And learn all the lessons. Oh, wow, the results here were much different from what I expected. And this is the reason why. And if I change it in this way, my experience changes some other way too. So sort of like learning to code again, which is like both daunting and kind of fun. So sort of jump in a similar way to how you maybe learned in the first place.
Awesome. Hey, we're almost at the top of the hour. It went so fast. I think we could continue the discussion the whole night. It's so efficient. But before we wrap up, anything you would like to say to conclude, and maybe if people want to continue the conversation, well, there's you are welcome on our community Slack of Port. It's a great way to a way to discuss. Patrick, you're pretty easy to reach as well on your page. if you search Patrick Debois on your page, you have all the the ways to discuss with you. But yeah, let's wrap up with one sentence each, and then yeah, we will get back to our life.
So my sentence would be, don't get discouraged. You still have to understand what good looks like to do a good job. So that's why you need to learn.
Okay, nice.
I really like that. I'd say from my side, we're just seeing more of what we've always seen, fragmentation, more tools, more complexity, and just try your best to find a way to navigate it and find a way to govern it inside of your organization as a platform engineer.
Awesome. Hey, Patrick, Elliott, the audience, Ronnie, thank you everyone for it was, yeah, I think we had, it was really insightful. Thank you so much. And again, thank you the audience for the great questions as well. And well, I wish you all a happy evening, afternoon, depending where you are in the world.
New Year? No, that's too soon.
Exactly. And see you all soon somewhere on the road. Okay. Hey, again, thank you so much.
Thanks for having us.
Bye-bye, everyone.
Yeah.
Bye.
Bye.